actually start the assignment. So if I give you something like this, I'm going to be very clear on what a function actually is. Okay? If I give you something like this, okay, what a function is, and I would just watch on this, okay? This is pretty, once I explain it to you, it's pretty straightforward. If I give you something like this, first off, a relation, okay? If I give you this right here, 1, 3, 2, 11, negative 4, 8, 2, 17. That's a relation, okay? A relation just means like ordered pairs. An x value with a y value, x with a y, x with a y, x with a y. That's a relation. Now this particular relation is not a function. It is not a function, okay? But if I make this negative 2, now it's a function, okay? Any idea why? And it's okay if you can't answer yet. And once we know it, it's really, really, really simple, okay? It's a function now, okay? And it didn't have to make it negative 2. If I made this 2 into a 15, it's a function now, okay? Let me give you another one that might make it a little bit easier. Here is a relation that is not a function. Well, I'll give you a function, and then I'll make it no longer be a function. So if I had 7 with 3, 12 with negative 6, 8 with 19. That is a function. That is a function. But if I did this, it's no longer a function, okay? Any idea why it's not a function? When I added 7, 15 in there, it made it no longer be a function. What's it? Oh, that's a good guess. It has nothing to do with the actual values of them, but...
There's the same number twice, but one's positive, one's negative.
Like which one? What do you mean? One's positive, one?
There's two.
Give me some specifics. What are you looking at? What number?
The 7 and then the 7.
What's 7 paired with?
7. The other 7 was 7, 15.
Yeah, well, what's the first one paired with? 3. 7's paired with 3. 7 is also paired with 15. That's no longer a function, okay? It's not a function, because if I ask you what 7 is paired with, you give me 2 numbers, okay? A function means for every input, you only get 1 output, okay? My input 7 has 2 outputs, 3 and 15. Now, if I make this negative 7, now it's a function. But what do I put this in here? How come it's not a function anymore?
Because it's already an
8 is paired up with 19 and 42. Now be careful here, okay? What if I give you this? 2, 6, 3, 6, 8, 7. What do you guys think? Is that a function or not?
Yeah.
It actually is a function. It is a function. Now, some people might go, oh, wait a minute, whoa, 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 whoa. 6 is paired up with 2, and 6 is also paired up with 3. You're looking the wrong way. Every x value has only one y value, okay? So it's kind of like this. I'll give you one that you guys can all relate to, okay? We had a test a couple weeks or so ago, okay? That's a function. And what that means is when you turn in one test, you input one test, I output, I hand it back to you, and give you how many grades? 1. If you would have handed in your test and said, hey, you know, what did I get on my test, K.O.? I said, well, you got a 94 and a 68. Your response should be, which is it? Is it 94 or is it 68? You can't give me 2 scores. That doesn't make sense, okay? Every input, every test turned in has only 1 score. Now, does it work the other way? Does every score go to only 1 test? Not necessarily. IOB might have got a 94. Well, it's not him. Somebody smart would have got a 94, okay? But is he the only one? Could another person have a 94? I mean, he has a 94, but 94 might go to somebody else also. She might have a 94 also. Jada might have a 94, okay? So it's not it just says every x value only has 1 y value. That's what makes it a function, okay? So if this right here, this is still a function. But if I plugged in, for example, 3, 11, that's not a function anymore because 3 is paired up with 6 as well as 11, okay? The input 3 has 2 outputs, 6 and 11, all right? So that's what a function is. Every input has only 1 output, okay? Also, I think you learned this in algebra. Maybe you did, maybe you didn't. And if you didn't, it's a real simple fix, okay? If I give you graphs, okay? If I give you a graph such as this, that is a function, okay? Yes, ma'am?
So you can't have the same value in the x spot.
Correct. Just be careful, though, because sometimes they might get tricky with you. And if I give you this right here, 4, 8, 7, 4, 8, 9, 11. Do you see the same x? Some students will say, well, if you see the same x value twice, like right here, I see a 3 and a 3, okay? Do you see the same x value twice on this one?
Yeah.
Yeah, what one? 4. Is that a function? It actually is. Why? It's sort of tricky. Because what's 4 paired up with?
8.
Yeah, you might say, well, 8 and 8. Well, you said the same thing twice. It's only paired up with 8. So
it's the
that
same.
would be a function.
Okay.
Yes. Okay. Now, if it was 4, 18, now it's not a function anymore. Okay. So I mean, if you want to take notes, I mean, it's just every x has one y, has only one y value. Okay. Every x has only one y value. Now, this graph right here, they're going to give you some graphs, and they're going to ask you about inverses and so forth. This right here is a function. Without knowing what the equation is, I know it's a quadratic. Okay. A quadratic function, so it's obviously a function. But this is a function. I didn't tell you why. And again, I don't know if you learned this or not in algebra, okay? If I gave you a line, that's a function. Actually, I know you should have been taught it in algebra, because I know I taught it this year in my algebra class, but it's been a couple of years, I might have forgot it, okay? If I gave you this thing, whatever the heck that is, looks like a W, that's a function, okay? If I give you this right here, a sideways parabola, that is not a function. Any idea why? Yes, sir.
Because on all the other 3, every point on there would have a different x.
How do you know that? I mean, every point does?
Yes. Because no parts are overlapping over the x-axis.
What? Okay. Let me ask you this. I'm not saying you're wrong. I'm not understanding how you're saying it. I'm going to give you an example. You tell me if this is a function or not. How about this thing right here?
Not a function.
That's not a function. How about this? Is that a function? Huh?
Not a function.
Okay. Say it one more time.
It's because if you plotted a point anywhere on any of those lines, it would line up with the x of another point.
Okay. He's totally right, but I'm going to try to make it even simpler. Okay. You're not. You're good. You said everywhere. You got to be careful. There's one spot.
Or a 0.
Right here. That one would have been okay, and that point right there would have been okay. Okay, but other than that, okay, then it would have been, it would not have been a function. I agree on that. Okay, there's a test, something called a vertical line test. Does that sound familiar at all? The vertical line test. I think you learned that in algebra. What a vertical line test is this? Vertical, straight up and down. Okay. Can I draw let's start with this first right here. Can I draw a vertical line anywhere and hit this graph in more than one spot? No. If I went like this, it hits it in one spot. Here, hits it in one spot. Here, hits it in one spot. There's no vertical line that'll hit the graph in more than one spot. That's good. That means it passes the vertical line test. It is a function. Here, hits it in one spot. One spot. One spot. One spot. It always hits it in one spot. Okay? This thing, once, it never hits it in more than one spot. Here, it hits it twice. Right there, it failed. You only have to do it one time, okay? You said there's a bunch of places it fails. It fails here, it fails here. You gotta be careful. It does pass right here, and there's other places it passes. It actually passes right there, okay? It doesn't hit it in any spots. So it can only hit it in one spot. It can't hit it in more than one spot. And if it fails it once, it fails. This fails the vertical line test. It is not a function, okay? This thing passes, up, bang, bang, bang. That hit it in 3 spots. That fails it. That is not a function, okay? This fails it. Fails the vertical line test. It is not a function, okay? All right, so now, that's something you should learn in algebra. Hopefully, if you forgot it, you know it now. Or if you didn't learn it, you know it now. We also have to find out if a function's inverse is a function, okay? So if I gave you this right here, we'll go back to this right here. This is a function. We've already talked about that. Is a function, okay? The inverse of it, whatever the inverse is the inverse a function? The answer is no, okay? And I didn't tell you why, okay? So the inverse is not a function, okay? If I gave you this right here, that is a function, but the inverse is not a function. Again, I haven't told you why yet, okay? Either somebody's going to figure it out or I'll tell you in a second. You shouldn't be able to figure it out on your own, but if you do, good for you, okay? if I give you this, this is a function, and the inverse is. It is a function, okay? The inverse, whatever the inverse is a function. Anybody want to take a stab at it while they think that hell they can tell? I'll give you a clue on this one. How did we determine whether something is a function or not? What'd you just say?
Horizontal line test.
Hold that thought. Okay, we just said a second ago, to tell whether it's a function, you need a vertical line test. To tell whether the inverse is a function, you use the horizontal line test. This is a function, passes the vertical line test. Does it pass the horizontal line test? No, it fails it. So the inverse is not a function. Whatever the inverse is, it's not a function, okay? This right here, it's a function. It passes the horizontal line test. I'm sorry, it passes the vertical line test. But, tell you what, this thing fails it right there. It hit it in 3 spots.
So it has to pass both vertical.
Right, so what I'm getting at is this. If I give you a graph, if it passes the vertical line test, it's a function. If it passes the horizontal line test, also, the inverse is also a function. But if it fails the horizontal line test, the inverse is not a function. Okay? How about a line? Whatever the inverse is that a function? First off, is it a function? Yeah, it passes the vertical line test. Is the inverse a function? Yes, it passes the horizontal line test, okay? So that inverse, whatever it is a function, okay? So that's something new, the horizontal line test. How about this one? And then we're gonna start the assignment, okay? Let's try this. Is the inverse of that function a function? Listen very carefully to how I say this. Is the inverse of that function a function?
No, 'cause it's not a function.
Very good. It's a trick question. Now let me ask this. Does this pass the horizontal line test?
Yeah.
But why did you say no then? Because I said the inverse of that function. You said what?
It's not.
That's not a function. Why? Horizontal. You're right. Jeez. I get you guys on and then I throw a curveball at you. It's not a function, okay? In order to have the inverse be a function, the first one's going to be a function in the first place, okay? All right, let's dive into the assignment, okay? We're on question number 22. 22. Oh, this very first question, there's going to be a question like this on our next test. And if you're like, oh, I better start, you can't miss this question. If you miss this question on the test, yikes, whenever our test is, okay? We talked about this yesterday. For the inverse, all you do is you switch your x and your y. That's all you do. So just watch this for a second before I actually do this first question. If I give you this right here, 2, 3, 7, 8, 9, 11. The inverse of that function, first off, that's a function, because every x has only one y. The inverse of it would be this. What did I do? Switch x and y. That's it. Is the inverse a function? Yeah, why? Every input has one output. So how about this? Let me give you this right here. 1, 6, 8, 6, 2, 11. Is that a function? Yes, it is. The inverse is 6, 1, 6, 8, 11, 2. Is the inverse a function? No, because 6 goes to 1 and 8, okay? All right. So, number 22. Let's actually do this question, okay? Number 22, when you get, let's answer this, then I'll tell you when you look at your computer, you'll be like, what the heck are they having to do here? You might have a hard time wondering how to type this in, okay? It's not, it's a multiple choice question, okay? They give you this right here on 22. This is the first question that we left off at. X and f of x. And they give us, what are the numbers here? 2, negative 1, negative 2. 2, negative 1, 0, 1, 2. And negative 2, 1, 4, negative 2, 1, 4. 7 and 10. Okay, to make it easier, when you see f of x, what are we going to do? We're going to cross that out and make it what? A y. Okay, what's the inverse of this? Instead of having, well, what am I going to do in everyday language? How am I going to find the inverse of this thing? Instead we switch x and y. So what are you going to do with this top row? Make it the bottom. What do you do with the bottom row? So, flip negative 2, negative 2, you're going to get negative 2, negative 2. flip the next one, you're gonna have what? Not negative 1, 1, but 1, negative 1, 0, 4 is gonna be 4, 0, 1, 7 is gonna be 7, 1, 2 10s, 10, 2. On your computer, while you're writing it down, maybe you do markers you're drawing up. On your computer, it's gonna be multiple choice. They're gonna say, here's a function. Which of these, you need to click yes or no. They're gonna give you 4 choices, multiple choice. They're gonna say, is this the right answer? Okay? If it's not, 3 of them are the wrong answer. Okay? I mean, what I'm getting at is this. That's the right answer. That's when you're gonna click. There's gonna have 4 choices. Choices A, B, C, and D. If it was A, I'm not saying it's A. I don't know if it's A. Is it A? Yeah, it is A. Okay? But B might have been this. They might have had this right here. They might have had. What did they do? Why is this the wrong choice? I mean, look at this and look at that. What did they do? Do you guys see it?
They took negative off the two.
Yeah, the x's stayed the same. They made -2, +2, 1, -1. They took the y values and changed them to the opposite. Is that how you find the inverse? You don't make that y's opposite. You flip-flop them. So here's what you do. For A, it's going to be yes, no. You click on yes. And then for B, you click on no. I think you actually have to click on yeses and nos on each of them, I think. I don't know.
So you gotta say no to each box?
There's only 3 choices. I think so. I don't know. We'll find out when we turn on the computers. Okay, let's do an easy one. Okay, number 31. A quick one. All right. They give you a graph like that. Very quick, ugly graph. Filling in the blanks, okay? This is, or is, let's see, is this a function? Oh, wait a minute, hang on. No, the inverse. Is the inverse a function? Is the inverse a function? No. So you're going to click and drag no. It says because the function does or does not pass what test? Does or does not pass it? Does not. Doesn't pass the vertical line test? Horizontal line test. Okay? So you're just clicking and dragging that. No, it does not pass the horizontal line test. 33. Same thing. Looks sort of like this. Is the inverse a function? No. Why? Doesn't pass. So let's see with the same answer. No, it doesn't pass. It's filling in the blanks, clicking and dragging. The horizontal line test. Is it a function? Yes, it is. It passes the horizontal or vertical line test, but the inverse, whatever the inverse is not a function. Okay, number 35. Okay, the last type of question. We're going to do the same question over and over and over, okay? Okay, here's what they're going to do. They're going to give you a function, and they're going to ask for the inverse, and then they're going to ask us, is the inverse a function? Okay, so they're going to give you a function. All right, so let's take this real slow. F of x is x to the, what does that say, third? X to the third minus 1. Think about what I told you so far today. First off, I told you this months and months ago. I see f of x. We're going to write down what? The y. Okay? So I'm going to just cross that out and make it a y. Based on just what I told you today, how do we find the inverse? We just did a question like it a second ago. What did I do with my x's and my y's? Switch them. So don't write y equals x to the third minus 1. Put x equals y to the third minus 1. Now you're not done. We did this Tuesday. Do we solve for x or do we solve for y? How come we don't solve for x?
Because it's already there.
You'd be done, and we're not done. So solve for y. So what do we do first?
Plus
1.
one.
So x plus 1 equals y to the third. Okay. And then how do I get rid of cube? Cube root. Oh, it is cubed. So we cube root it. Cube root this side, cube root this side. So we're going to have the cube root of x plus 1. Okay. That's the inverse. Okay. I'm just going to tell you right now that the inverse is a function. Okay. So what are they asking us here? The inverse is this, and the inverse is a function. So yes, you're going to click on yes, the inverse is a function, and that's the inverse. I'm not going to tell you why yet. Okay, it's easier to tell you why something is not a function. And we're not there yet. Yeah, we are. Wait, 30. That was 35. 37, we want to do? Yes, 37. Oh, no, this is another easier one. Okay, 37. No, I tell you what. I'll explain this one before we move on. I cube rooted each side. We talked about this Tuesday. Did I forget to put a plus minus symbol there? Was I supposed to put a plus minus symbol?
No.
When do you put a plus minus symbol?
Square. Or
Square
even.
root or, not just a square root, an even root. Three's odd. You don't put the, very good, that's great that you guys remember that, okay? When you take an odd root, don't put a plus or minus symbol. Just watch for a second here. If I give you this right here, y equals x to the fourth plus 2, okay? Just watch on this one, okay? So let's find the inverse of this. So we switch them. X equals y to the fourth plus 2. We subtract 2. And we have x minus 2 equals y to the fourth. Okay, then what do we do? How do I get rid of a fourth power? Fourth rooted. Fourth rooted. Do I put a plus minus symbol there?
Yeah.
Yes. So plus or minus fourth root of x minus 2. Okay. Is that a function, do you think? No, it's not. Why? What makes it not be a function? When I plug in one value for x, how many y values are we going to get? 2. How come 2? There's a plus minus symbol there.
Oh.
Okay, because of the plus minus symbol, okay? So, that would not, the inverse would not be a function, okay? So, how come this is a function?
It's odd.
And there ain't no plus minus symbol there. There ain't no plus minus symbol, okay? And that's why it was odd, that's why we had no plus minus symbol. Okay, number 37. Okay, so we have f of x is x plus 4. F of x equals radical x plus 4. Okay, first two steps are real simple. First step's really easy. What do we do?
Change it what?
Change f of x to y. Second step isn't much harder. Switch x and y. So x equals radical y plus 4. And then we have to solve for y. That's the only hard part, and that's not really that difficult. It just takes a little bit of work. So what do I do first? How do I get rid of that radical?
Square.
Square both sides. If it was a cube root, you'd cube it. So we have x squared equals, these cancel, y plus 4.
5. Or it is 4. I don't know why I wrote 5.
Oh, okay. Then what? Subtract 4. So x squared minus 4 equals y. Is that a function? Don't think hard on this.
Yes.
Why? Yes, it is. Why?
Because there's one x.
Okay, there's an even simpler one. If I give you this right here, say the inverse turns out to be this. Y equals the 6th root, x minus 2. Just by looking at that, is that a function? Why? Plus minus. Is that a function? Yeah, why? Because ain't no plus minus. So yes, that is the inverse is a function. Okay, just a few more, and then I'll turn you guys loose. Number 39. Yeah, 2 more. 39. All right, number 39, we have, is that a cube root? 2 cube root x minus 5. F of x. 2 cube root of x minus 5, I think it says that. Look one more time. 2 cube root of x minus 5. All right, so let's change f of x to y. Some of you guys, any of you guys is writing down y to start with? That's what I usually do. I wouldn't write f of x. Some of you might even skip that to the next step. Not even write y, but you might write just x. X equals 2 cube root of x minus 5. Now it's been a while, probably at least a week and a half or so since we've done something like this. How are we going to get rid of that cube root?
Cube root.
It is cube root. How do you get rid of cube root?
Cube root everything.
Say it again?
Cube root everything.
Not cube root. We are cube rooting. What's the opposite of cube rooting? Cubing. Cubing and cube rooting are not the same thing. Okay, we're going to cube each side. We're going to cube each side right now?
No.
No. Why?
Because we have the x and y.
Well, we're not ready to do it yet. We got to do something else first. What's there that we don't like? Get rid of the 2. You got it? Huh?
Oh, sir.
You wrote x twice.
Oh, thank you. Yes, I'm sorry. Thank you very much. Sometimes I do those Steve, you guys catch them? That's just me, I just
You
screwed that
can
one up.
switch that.
Okay, I switched them, but I forgot to change it forever. Remember, before you cube each side or square each side or whatever each side, you gotta have it all by itself. So we gotta get rid of that 2. How? By subtracting 2?
But
Dividing by 2. So x over 2 equals the cube root of y minus 5. Okay. And then we need to,
Don't you have to divide yours?
well, I didn't show it. If I divide it, it's gonna cancel. I didn't. If I do this, divide 2, they cancel.
So it wouldn't do anything to the y minus five.
Well, the 2's canceled.
That's it.
Oh, so you're not dividing it all?
Well, I mean, it's like, I don't know how to say
Because
this.
it's on the outside of the.
Yeah, it's not in, yeah, we don't divide the y in, we don't
Oh,
divide,
okay.
yeah, we just divide this side and that side. Okay, so now what do we do?
Gotta get rid of it.
Cube each side. Do I put a plus minus symbol?
no.
Listen carefully, because some of you guys, and I'm not making fun here, some of you, I think are still I don't know if you're just struggling with the way you're saying it, but like when you say like cubing and cube rooting, those are not the same thing. Okay, they're total opposites, okay? It's like saying adding and subtracting are the same. No, they're not. They're opposites, okay? So, to get rid of cube roots, we cube, okay? Do we put a plus minus symbol then? Listen carefully. You only put a plus minus symbol when you what? Take an even root. When you take an even root. We're not even rooting. We're cubing. Cube this side. Cube all of this side. So cube x cubed is x cubed. Over 2 cubed, it's not 6, it's what? 8. 2 times 2 times 2. These cancel, we're left with y minus 5. What's the last thing we have to do?
Plus
Plus 5.
5.
So we have x to the third over 8 plus 5. Is that a function?
Yes.
Why?
No plus.
No plus minus. You're thinking, man, they're all going to be yes. Well, the ones we've done so far. On your assignment, they're not all necessarily going to be yes. Last one I'm going to do with you guys. 41. Okay, so we have x to the 4th plus 2. F of x is x to the 4th plus 2. Oh, warn you guys, we might have Hoppa in here tomorrow. He's struggling a little bit. He said he's going to come in Friday to get some help, so. Leland Hoppa. Isn't that how you say his name? How many W's are in Hoppa? 2 or 3? 36? Okay.
A lot.
All right, so
So many.
change f of x to y, and then switch them. So x equals y4 plus 2. Okay? Again, I want to make sure we understand this. True or false? To get rid of a 4th power, we 4th root it. Is that how we get rid of 4th powers? We 4th root it? You guys are thinking way too hard.
Yeah.
Yeah. We're going to 4th root it right now?
No.
No. What do we got to do first? Get rid of the 2.
Or subtract the two.
Subtract 2. X minus 2 equals y to the 4th. How do we get rid of a 4th power?
Fourth.
4th rooted. 4th root. 4th root. So we have the 4th root of x minus 2.
No function.
Why? The way I've written it? The way I've written it is it a function? The way I've written it is,
Yes,
but I made a mistake.
It has to be a plus minus.
I didn't put the plus minus. Now it's not a the inverse is not a function. The original one's a function. The inverse is not. So what does that tell you? If I graph this, if this is a function, what test would it pass? Vertical. But if the inverse is not a function, what would happen? It would fail the horizontal line test, okay? So it's not. The inverse is not. This is a function. The inverse is not. Okay? Does this seem easier than yesterday? Or I think it's a lot easier, okay? All right. So tomorrow, I think, is a work day in this class. Let me just check real quick. Okay, let's see here. It's due the 19th. I think, yeah, or what is tomorrow? 6. Yeah. Tomorrow's a work day, okay? You should be able to get a lot of this done today, though, I think, okay? We'll still make tomorrow a work day.
How do you type in plus minus?
Good question.
There's a plus minus on
Don't you have to